Bismillahirrahmanirrahim. Assalamu alaikum students. I am Sabir Hasnan, your science subject teacher from grade 8. In this video lecture, we will discuss about electricity and energy from chapter number 7. If you remember, in last 2-3 videos, we discussed about the basic concepts: energy, types of energy, conversion of energy, and later on the law of conservation of energy. Then we discussed Sankey diagrams, and after that we discussed power supplies and voltage, how to determine potential difference of voltage by using voltmeter, and at last we discussed about resistance and the factors which affect resistance in detail. Now our aim is to discuss how to control the flow of current in a circuit. Definitely, if you remember the previous video, we discussed about resistance, and you know the resistance is actually the opposition to the flow of current, or the opposition to the current flow is called resistance. So in other words, we will use resistors to control the flow of current in a circuit. So thus, controlling the current, the flow of current in an electric or electronic circuits can be controlled by using resistors. There are major two types: fixed resistor. Fixed resistors are actually those resistors having a same resistance, and their resistance will not change or will not vary at any cost. And secondly, we have a variable resistor, and variable resistors are actually those resistors in which we can vary the resistance of a circuit. Here, look at these figures. Here, this middle one, we have a fixed resistors, okay, and on the right side we have a symbolic representation of a fixed resistor. We can represent by any way, either this one or this one, okay. And on the most left side we have a variable resistor. This variable resistor actually control the flow of current by varying resistance. In this case, by increasing the resistance, the current in a circuit will be decreased, and by decreasing resistance, the current in a circuit will decrease. One of the example to control the flow of current by using a variable resistor is a regulator of an electric fan. You know, in regulator, when you move the regulator 1, 2, 3, 4, 5, and you know 5 is the highest position where the fan speed is the highest. So in this case, more current flows through the circuit, and when it is a 0, the resistance would be the maximum, that is infinite resistance. And similarly, when we move towards 5 to 4, 4 to 3, 3 to 2, then 1, that actually increases the resistance and decreasing the current in a circuit. Now, resistors are used in electronic circuits so that the right amount of current is fed to the different components to make them work properly. This is very important point. If we look at the charger of our mobile phone, our mobile phone needs a very small amount of current in milliampere or in microamperes. If we attach a source we provide a direct current to the mobile phone, there would be a blast, because the amount of current is too much higher as compared to the required in case of mobile phone. So definitely the charger of mobile phone, actually in charger there are different resistance and there are different circuits which control the flow of current over there and provide the accurate amount of flow of current to that circuit. So that's why they are used as are used to control the flow of current. Now, in case of variable resistor, as I told you earlier, in variable resistor we can adjust or vary the flow of current. It's up to us. Either we can increase the flow of current or we can decrease the flow of current. On the right side of the figure, there is a symbolic representation of the variable resistors. Rheostat is another example as a variable resistor. Question is this: how the resistor resistance varies in a variable resistor? Okay, like the regulator of a fan. So if you remember the previous video over there in which we discussed about resistance is directly proportional to the length of the conductor. If length increases, then resistance also increases. If length decreases, resistance also decreases. That's why in variable resistor, so variable resistor actually has a sliding contact. So variable resistor has a sliding contact. As I told you, one of the example is a rheostat. You will learn the rheostat in higher classes. Okay, so in rheostat or variable resistor, in this case contact moves and the length of the resistor changes. The length of the resistance Y changes with the change in current. So when length increases of the conductor, in that case length of the resistor increases, and which actually reduces the current in a circuit. If we consider a perfect resistor that always have the same resistance, for example, if we have some resistance and we call it has a perfect resistance of 1000 ohms, that will remain 1000 ohms. But in real cases, the resistance may vary from its ideal position, maybe 10% or 5%, whatever that would be. Let's suppose if we say a resistor has a resistance 1000 ohm, then its resistance may vary 10%. So 10% maybe that would be greater than 1000 or less than 1000 by 10%. It means that would be around 900 to 1100. And look at these two figures. In the voltage, when voltage is doubled, the current also doubled. So voltage and current, they are actually directly proportional to each other. As you know, I told you in the class as well, a voltage is directly proportional to the flow of current, or the current is directly proportional to the flow of voltage according to the Ohm's law. So voltage, keep in mind, voltage is an independent quantity and current is dependent quantity on the voltage. So the graph would be a straight line which is inclined to x-axis, and here is a figure of, we have a variable resistor, we have A for ammeter and V for voltage. This variable this ammeter actually measures the current, and this ammeter measures the current in a circuit. So if resistor varies, variable resistor, due to the increase in resistance, this ammeter measures the current which is decreasing, and here we have a resistor, a fixed resistor over there. We will measure the potential across it. And look at the figure again. This figure shows the voltmeter is connected in parallel to measure the voltage. So ammeter is always connected in series and voltmeter is always connected in parallel to measure the voltage. I hope you learned a lot from this video. In next video lecture we'll discuss about the current at our homes. So